In the last section, we took a look at categorical data and how we can try to summarize it and interpret it by using graphical measures. Now what we're going to do is we're going to move on to quantitative data, which is a little bit more difficult to deal with because they're not always going to be very nice whole number or discrete values. So remember that quantitative data is any data that's described using numbers. And instead of just utilizing an adjective, what we're going to do is we're going to use, instead of a category, we are going to have a bin, or sometimes we call it the class. Okay, so sometimes we have a bin or a class, and you'll probably hear me refer to those interchangeably, to which an observation is going to fall within. Right? Now recall that the number of times that a specific observation lies within a class or a bin is the same as the frequency, and that's the same term that we used for how often an observation falls within a category. Remember, we had a frequency distribution, and frequency distribution is going to be that table. And remember, the frequency distribution that we used before not only had the frequency, but also the relative as well as the cumulative frequency. Something new that we haven't seen before is the idea of this formula, C equals 1 plus 3 plus 3, 1 plus 3.3 times the log of n. All right, that's called Sturgis Rule. And what Sturgis Rule does is it tries to approximate the number of classes or the number of bins that are going to be in the frequency distribution. N is the number of observations that we have. That's the sample size. Remember, we said that N is our sample size. And whenever we see the lowercase letter c is the number of classes. And again, this is an approximation. And once we have the number of classes, then we can figure out how wide the bins are going to be. All right, so each of the classes is going to have a standardized width, and that's going to be found by high minus low divided by c. And then we might have to round that off to the nearest integer. If we have to do that, then we shall do so when the time arises. All right, so what I'd like to do is I'd like to illustrate how we're going to go through and how we're going to be able to find the frequency distribution for one of these types of quantitative measures. So let's say, for instance, that the data that we have below represents the grades for a Math 216 final examination. And we want to construct a frequency distribution for the data, and we're going to include both the cumulative as well as the relative frequency. And of course, we want to use Sturgis Rule to construct the classes. All right, so here's how we're going to do that. We can't just go through and write yellow, blue, red, green like we did before. We're going to have to do a little bit more scientific sort of study or investigation when we have this quantitative data. So the first thing that we need is we need the number of samples. Okay, so we need our sample size n, and n is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there are 13 samples that we have. So now we're going to figure out, by using this formula, the approximate number of classes. So we're going to say that C is going to be equal to 1 plus 3.3 log of 13. And what we're going to do is we're going to put that into our calculators. All right, and you're just going to go ahead and after this is done, I'll show you in a different video how to enter that into your calculator. And you can go ahead and do it along with me if you choose to. The value that I'm going to get for this is going to be 4.676. And remember, what we like to do is we like to round to 3 decimal places if at all possible. All right. Finally, we're going to get the width, W, right? And the width, W, is going to be high minus low divided by C. Notice the highest observation is 10, the lowest or 100, excuse me, and the lowest observation is 61. So we have 100 minus 61. Okay, so we're using this formula. And we're going to divide it by C. And what's C? Well, it's going to be that 4.676. Now, be careful. When we're putting this into the calculator, we want to make sure that we put the numerator in parentheses. Right? So the width for this is going to be, if we approximate it, just give me 1 second, and I'm computing off to the side. And so W for us is going to be about 8.340. All right. What we'd like to do is we'd like to round this off to the nearest whole number. Okay, so the nearest whole number is going to be 8. Okay, so this tells us two things, that there should be about 4 or 5 classes. Okay, and we don't want to round C because then it's going to make our W inaccurate, and that the width is 8 for us, which means that there are going to be 8 possible observations in the class. All right. So now we're ready to go through and actually construct the frequency distribution for this thing. All right. So I'm going to copy this because we do need these numbers again. So we'll just copy these really quickly. That way we don't have to keep scrolling back and forth. All right. And so we're going to start off with the classes. So now the lowest number that we have was 61. For some reason that didn't copy down. So let me put that in there. So the lowest number we had was 61. And so our lowest bound, or the lower bound for our class, is going to be 61. Now, a lot of people would just add 8 because the width is indeed 8. All right? But think about this and count it on your fingers. Okay? Go from 61 to 69 if you add 8. So you would have 61, 62, 63, 64, 65, 66, 67, 68, and 69. Well, that actually means that there are 9 possible observations and not 8 possible observations. If you don't believe me, count it on your fingers. All right? So we're not going to add 8. We're actually going to add 7. And that gives us 8 possible observations. Okay? So hopefully that makes sense to you. But what you might want to do is just start with 61 and then count up 8. So 61 is 1 observation, and then 62, 63, 64, 65, 66, 67, 68. All right? Another way to think about it is just add 1 less than whatever W is to be able to get to the upper bound. All right, so what's the next class look like? Well, we're going to start with 69. And then we're not going to add 8, we're going to add 7 to that. So if we add 7 to 69, that's going to end up being 76. And then we're going to have 77 as the next class. And we're going to add 7 to that, so that's going to be 84. And we can see the pattern here. 85, we're going to add 7, 92. And then finally, 93, add 7, that's going to be 100. All right, now notice we don't have to go any higher than 100 because 100 is the highest observation. All right, so again, notice that each of the bin ranges or class ranges is going to be 8. Even though there's a difference of 7, we have to include that lower band. After that, the rest of the frequency distribution is pretty easy. Okay, so we're going to have the frequency. I'm just going to abbreviate frequency. So notice that there are 2 observations, 61 and 65, that fall between 61 and 68. Notice that between 69 and 76, there's only 1 observation. And then between 77 and 84, there are 5 observations. All right, so even though 79 is repeated 3 times, 5 observations. And then there's going to be 2 observations between 87 and 92, not 2. And then finally, We have these last 3 observations that are going to be between 93 and 100, right? A good way to check to make sure that you've captured all the observations is just to add up the frequency column. All right, so we have 2, 3, 8, 10, 13. And that's good because remember initially we said that n was equal to 13 all the way at the beginning of the problem. All right, so if it's not equal to 13, then we probably want to go back and recount either initially or recount what we just did. All right, the rest of the problem is pretty easy. We have our relative frequency. And I'm just going to leave these as fractions, right? Just because we can know how to set these into the calculator. So we have 2 out of 13, we have 1 out of 13, we have 5 out of 13, we have 2 out of 13, and then we have 3 out of 13. All right, so remember, relative frequency is just going to be the ratio of the frequency to the overall number of observations. Finally, we have our cumulative frequency. And the first one's going to be 2 out of 13. And then remember what we did last time was we just added. So this is going to be 3 out of 13, and then 8 out of 13, and then 10 out of 13. And the good news is we end up with 13 out of 13. All right, if that's not 13 out of 13, then we're going to have some issues. All right, then we have to go back and count. All right, so hopefully this helps you to illustrate how we're going to go through and how we're going to create a frequency distribution for our quantitative data. Now, you might recall in the last videos, what we did was once we had the frequency distribution, we started making graphical measures. And that's exactly what we're going to do, is we're going to look at the different graphical measures that are possible for quantitative data, and then we're going to construct them, and then we're going to analyze